AI reshape the system of an improvisational dance class, and what contradictions emerge between traditional pedagogy and AI-mediated co-creation? So what is Lumini? Lumini is an AI dance partner that can improvise with you in real time. Lumini operates through 5-module system. First, it detects and segments dance motions into 3-second chunks. Second, it analyzes the movement utilizing Laban movement analysis and viewpoints theory, looking at parameters such as energy, tempo, and size. Third, it learns interaction patterns based on how much and how creatively the dancer moves. Fourth, it selects a complementary response using similarity matching. And the fifth stage transforms the response using one of the 10 movement strategies that was put together along with our dance collaborator. To answer our question, we ran a 3-month contextual diary study at Kennesaw State University as a part of a 3-year project that was aimed at enhancing the design of Lumini with pre-professional dancers. Here you see a video of us collaborating with the dancers. We recruited 10 college-level BA students, so Bachelor of Arts students, and 1 instructor. 9 of our participants identified as female and 1 as male. And there were undergraduate students pursuing majors in dance, theater, psychology, exercise sciences, and had between 4 to 18 years of professional dance and choreography experience across many different styles, such as modern, improvisation, jazz, tap, Afrobeats, African hip-hop, among others. The students also had been involved in dance performance between 1 to 10. Are people just logging in? Okay, I should ignore that. Is it okay if there's... okay. Is there any way? It's a little bit hard to concentrate when I hear myself talking. So it maybe, I think it needs to... I think this person needs to be muted. Here we go. What does that say?
I just need to...
Sorry, it's all in Portuguese. Okay, great. So the students have also been involved in dance performance between 1 to 10 times in the past year. The instructor, who self-identified as a female, had over 21 years of teaching experience. So what was our class structure? Each 75-minute class followed a very structured progression that we carefully constructed with the dance professor ahead of time. So we began with a 15-minute warm-up that focused on announcements and physical preparation. Then we had a 20-minute concept exploration that introduced improvisational techniques that were spearheaded by the dance professor. And then the core of the class, about 30 to 35 minutes, was spent on engaging with Lumini, focusing on movement, exploring movement qualities such as weight, space, and time, some of the Laban parameters. And in these sessions, students collaborated in small groups to refine the sequences that they made with the AI interaction with Lumini in preparation for a performance. And finally, following every single class, we had 10 minutes to allow for all of the journaling or the data logs. So we conducted this study over 11 class sessions over a 13-week period. So the data collection included 4 different components. First, we did a pre-questionnaire that was distributed to both students and the instructor. As you can see in the videos, that there was we had live music, but we specifically chose to exclude that from the study. Second, after each session, everyone completed a structured 15-item questionnaire. Third, we had 2 written reflections from the student, one in midway through the semester, we're used to doing very fluid, jerky movements, but with the AI, that to slow down in order for the Connect to be able to capture their movements in a more adaptable way. So that was really frustrating at first, but over time, the students adapted and they started working with the system's imposed limits, even treating the glitches as creative prompts. So the classroom began to shift from striving to have perfect execution of their movements to embracing experimentation and play. So when we look at the community dynamics, while initially isolating, AI eventually became a shared challenge, and through discussion and observation, students began to rebuild group trust around experimentation. Two quotes really stood out to me during the data analysis. One of the students said, "At first, I felt like we were thriving by creating a semi-sacred space sans technology. Then suddenly, we were being observed, and the AI was this third presence in the room. So they didn't really." It wasn't really welcome to begin with, and it was something that it was an alien right in the room that was observing all of their movements. And the instructor said that it felt like some students withdrew when the AI was being introduced. It was like they were waiting to see how others handled it before engaging themselves. So throughout as time went on, they became more used to the idea of incorporating it into their workflow. So when we look at the division of labor and how Lumini affected human and AI roles, with Lumini in the classroom, the instructor's role shifted. So from guiding movement directly to designing experience around the AI. So students took a dual role, so not just dancing with the AI, but teaching it. And one dancer said it felt like teaching a child how to dance. And as the AI began retaining their movement traits, students noticed a sense of co-evolution, prompting both awe and a reflection on the growing agency of AI in the creative space. So when we look at our outcomes, the biggest shift wasn't technical, it was cognitive. Students learned to break patterns, reflect more critically, and embrace failure as part of improvisation. They adapted to technical limits and began co-creating with the AI, refining their improvisation, problem solving, and their awareness. And the final performance reflected this growth, and still many felt that Lumini lacked emotional depth, limiting its artistic impact, which was kind of common to see in this instance, as we're not reached yet those limits. Or that promise. So while it showed promise for choreography and research, the true integration will depend on enhancing its expressiveness and sensitivity, which we're focusing on in future work. And when we look at the contradictions that emerged, contradictions surfaced at many levels. So students felt torn between curiosity and frustration, unsure of whether they should be simplifying their movements for the AI or to stay true to their style. So that there was a little bit of this a contradiction that occurred there. The instructor balanced excitement with the challenge of keeping improvisation more organic, so that to give enough prompt, but also allow enough freedom for dancers. And even Lumini itself revealed tension, promising co-creation, but often glitching or failing to respond. There are also system-level conflicts. The AI limited expressiveness, lacked emotional reciprocity, and its sole interaction model disrupted group cohesion. And at a deeper level, students encountered a clash between traditional improvisation, which was fluid and very social in nature, and the structured demands of dancing with the AI. And beyond the classroom, some even questioned AI's place in their future careers, wondering whether it will replace artists instead of supporting them, depending on how designers choose to design them. Institutions also struggled with the logistics of sustaining such experimental tools. And so all of these tensions disrupted the process, but also deepened it, prompting new reflections and creative strategies. So there's 4 critical lenses that emerged throughout this process. And so we're going to unpack those pretty quickly. Sorry, I'm a little bit over time here. So first, when we look at space, not as a fixed container, but as a living negotiation, Lumini really challenged the spatial logic of the dance classroom, turning traditional boundaries into elastic responsive zones, and this really defined how dancers engaged with movement, presence, and visibility. Next, when we consider the role of AI in the creative process, rather than acting as an autonomous improviser, Lumini behaved more like a learner, one that relied on human dancers for instruction, pacing, and engagement. And this reframes AI not as a partner, but as a co-regulated participant. And then we consider creativity and authorship. Lumini functioned less as a source of novel ideas and more as a reflective mirror. So helping students become more aware of their own patterns, but really surprising them. Finally, when we zoom out, AI in dance isn't just a technical experiment, it carries cognitive, cultural, and ethical weight. And Lumini prompts us to reconsider what movement means, who defines it, and whose styles get recognized. So the main takeaways here that I want to leave you with is that improvisation is no longer just between bodies, it's between systems. Students didn't just move with other humans, but with technical constraints, reflective systems, and social cultural norms. AI doesn't eliminate spontaneity, it relocates it. Students become spontaneous not because of what AI was, but in the response to its constraints. We're not just designing technology for dance, we're choreographing technology itself. So the instructor here became a system designer. Students reshaped the AI through feedback, and the choreographic act extended beyond the body. Number 4, teaching improvisation with AI is less about the movements and more about the mindset. So this work lives in response to how students look to about tension, failure, and adaptation, and this is really the core of improvisational growth. And the goal isn't to humanize AI, it's to rehumanize how we relate to it. AI isn't just a tool, it's a mirror. What we build into it reflects on what we value, what we forget, and what we're willing to challenge. Thank you.
All right, thank you so much. I actually have a quick question to kick this off because you mentioned at the beginning that there were different types of dancers.
Yeah.
So I wonder, did you see any differences among the type of dancers, how they felt about it?
So all of the dancers, mostly when you're studying dance, you have a lot of different backgrounds. So you're subject to different types of dance styles to begin with. So all of the dancers had a modern dance background primarily. So we didn't really see, there was differences in the way that they like to move that was complemented by their dance background. So for example, if someone had a more jazzy background, that reflected to the style of their movement patterns, whereas someone that's coming more from maybe from Afrobeats or African dance, that's going to result in different sort of movements that they choose to dance with the AI. So we actually, throughout the system design, we actually tagged the dancers' names, so that way the AI could begin to recognize, oh, these are Sally's movements, and this is very different from Tom's movements. So we begin to create their own style and reflect, be able to reflect on what the AI looked for in each dancer.
Okay, great. Just forward is the way.
Thank you, Mika, for the presentation. Your results present some of the perception of the agent through the sensors.
Yeah.
And I just want to hear about this reflection. What is the sensor? If the sensor changed, it was the AI problem or just a sensor problem in some of the results? Or just to hear about that, if you change the sensors.
Yeah, so we used a Connect. So Lumini is a 12-year project. It's gone through many different stages. And so because the focus of the project was more so about understanding the improvisational practices of dancers and realizing, like, how can we change specific parts of the system, not necessarily the perception part. Meaning, if we change to something that was a human pose estimation model, we used a system like Move AI that had more accurate motion tracking. I do think that it would have had a difference, I will say. And this is something that is, off the bat, that realizing that what you actually present as part of the feedback, when we talk about feedback, are those movement responses. So it doesn't really matter what sort of interaction dynamics you embed, what sort of intelligence you embed into the model itself. It's really about the motion tracking itself. Yeah. So the Connect and most of these human pose estimation systems were optimized for layman movements, not necessarily for dancer movements. So even the dancers would kick their leg up to their ear, that the model wouldn't really do that very well, at least the Connect model. So that's something that we realized early on, but then you had to reframe whatever the research goals were. So that's something that I would probably, in anyone doing dance research, it's really important that there is accurate motion tracking, and however that looks like, right? If it's non-invasive, it's very different than actually having marker-based. But then dancers don't like marker-based, so you always like facing different sort of contradictions and challenges. But yes, a short answer is yes.
This is actually a fairly simple question, but could you just define what you mean by it's to rehumanize how we relate to it? Exactly. Like, I'm not really sure what you mean by it, or like how that works.
Yeah, so I think it's really important that we really think about this as a tool, a way that you can bring in dancers into the fold, rather than just making it more, right? For example, a lot of the dancers and a lot of the dancers really wanted the agent to look like themselves, but then when you make it too human, it becomes more of the uncanny valley. So it's how you begin to form the perception of what you can actually gain from it, and that this is not a tool. We're not trying to replicate human movement, that's not the sole purpose of it, even though we see that often with different AI-based tools. I would say that it's just reformulating maybe our perception of what you can do with it.
Yeah, so is it like more like expectation management in a way?
Yes, right, that as well.
Yeah, cool.
That's a component, yeah.
Hi, great talk. I've got one question. Basically, in your development journey, as you develop the tech, because you get glitches, etc., and this kind of thing, did you find the dance inspiration was impeded by glitches, or was it enhanced by glitching?
So at first they thought it was impeded, but actually it helped them reformulate the way that they could move in different ways. So the glitches actually inspired them, and in a way that when they see movement that is unhuman, that inspired them to move in different ways that they wouldn't have thought about. Because a lot of movement that dancers do, one of the challenges with improvisation is that you're stuck to your own habits. So you do what feels comfortable, you do what feels good, more importantly, what looks good, right? Dance is a very aesthetic art form. So unconsciously, you're doing the same movements over and over again. And this is where I think embedding more of a data-driven layer pulls dancers out of this consciousness that really thinks them, allows them to think about different ways in moving their body that they didn't think about. So the glitches actually inspire them.
So in terms of keeping these glitches, keeping the glitches as a database in terms of archived glitches and actually throwing them into the mix.
Exactly.
Yeah.
And making them unpredictable, I think that's one of the toughest things, is how do you, after a while, when Lumini starts learning some of your movement patterns, is how do you make it still maintain that unpredictability so you can surprise them in new ways.
Interesting. So a broken machine can help you be inspiring.
Yeah.
Cool.
Which is something that I think was unexpected, that we tried to make it more predictable and less glitchy, but it had the opposite effect. And that was similarly found to other Benedicta Walla's work. This is a similar work that had similar results.
Yeah, really interesting, cool.
Well, let's thank Milka for a wonderful presentation. And I'll ask the next presenter to come up. We'll need some technical help, which is on the way. Yeah, it's we got it. Yeah. All right, so we have the next presenter ready to start. So Tunde will be presenting Measuring Creativity in Co-Writing with AI. So whenever you're ready, I'll put on my 8 minutes.
Is this any better? Splendid. So I won't go through the title because you can read that. I should just frame this by saying to everyone, I'm talking particularly about English poetry. So other languages beyond German, I have no idea whether some of the rules are the same. And then secondly, there's no jargon, so for those of you that are deep machine learning types, you might be disappointed. This is more about arts. Right, so purpose of our research, essentially, my colleague there, Mark, who'd asked the final question, will do the second part of this on Thursday, is essentially what our studies are interested in is looking at augmenting human capabilities insofar as creativity. That's essentially it in a nutshell. Tools that can help people become more creative or express themselves in different ways. And poetry and lyric writing is a particularly central part of why we're looking at what we're doing. Why poetry and lyrics? I think for a number of reasons. Essentially, I won't go through all of these, but the key ones are probably that it's actually very familiar to people, which is important. It's quite short, which means you can implement things very well. You tend not to write poems that are, 1,000 pages or hundreds of pages. It's very structured and yet extremely flexible at the same time. So if you think of if you gave somebody a constraint to write a poem and it had to rhyme, for example, there's many, many, many different ways of doing that. And that's actually quite important in terms of computational linguistics because we can do small things that can be quite densely packed, but people can express themselves in lots of different ways to do them, which gives us obviously reasonably rich data sets. Final parts are that it's extensible because we can then use the voice, we can maybe even use images, we can use various other things. And then the final part I think is actually the most important, is it should be fun. So most of you, I'm sure if I ask you, will have a favorite song. In fact, who here doesn't have a favorite song at all or doesn't even like music and doesn't like lyrics? Someone nearly put their hands up there. I see you, right, we'll talk afterwards. Anyway, most people like lyrics. And so that's one of the reasons we try to do it. The particular study that we're looking at was looking at rhyme density. And just at a high level, effectively one way to think about it is rhyme on the one hand is very simple, right? Cat, sat, mat, etc., etc. On the other hand, it's actually very complicated because if you think of everything from a strict rhyme to words that don't really rhyme, but if we get them linked and packed in a particular way, and hip hop would be a good example, you can actually give the appearance of a rhyme. So if I think of something like, I don't know, an Eminem lyric. I'm not a lyricist, by the way, in terms of an MC, so anyone who is, cover your ears. There's a lyric in The Monster where he says, "Excuse me, I just want to be the Bruce Lee of loose-linked abused ink." Right? And that's quite nice because there's a real flow there. But actually, if you analyze it, none of those words strictly rhyme. It's just the U sound in the middle, right? So, but it actually works. And that's one of the things that we think we can do that's really interesting if we look at rhyme, is that we can go from strict rhyme. So, I don't know, Shakespeare's sonnet, I think it's 118. Shall I compare, I'm going to try and remember this here, which is, goodness, rough winds await the Charlie's Acre of May. Actually, I can't remember that poem, it's really embarrassing. I'll give August Henley instead. So, out of the night that covers me, black as the night out of the night that covers me, black as the pit from pole to pole, I thank whatever gods may be for my unconquerable soul. It's not quite right, but that's from Invictus. So there you have strict end rhymes, whereas the Eminem one I gave the example of, you just have these kind of ooh sound in the middle. That gives us some flexibility, and that's obviously the kinds of thing that we want to play with. And what it means is that from our point of view, we can also look at doing rhyme computationally, but also humans doing it of different skill levels. And it's quite nice to have rhyme density just as one metric, right, that we can analyze kind of software and not analyze people. And then the final part is that at the moment, at least, I think we would argue, we appear to be some way off software being able to rhyme as creatively as human beings. And I would certainly argue as a poet, I think we're a fair way from that and a very long way. As opposed to, and again, if there are any lawyers here, I don't want to kind of disparage your profession, but if we look at law, maths, maybe even chess, Go, there's a bunch of things where increasingly the most powerful AIs are beating kind of, quote, state-of-the-art humans. I think that's a fair while, and me and Mark would argue it's a fair while before we're seeing that in music, in poetry, and a bunch of those things. And that's actually quite important because it gives us quite a long runway to explore some really creative, computationally difficult challenges. Here's an example, I suppose, if I talked earlier about how you may analyze rhyme and just a visual of the kinds of multi-layers at which it could work. The experiment setup that we looked at was reasonably quite straightforward. We had something called the diverse associations task. Essentially, you pick 10 words in under 4 minutes, and the words should be as semantically varied as possible. So if you think of, I don't know, cat and atom, they're obviously further away in terms of semantics than cat and dog. That's essentially it. You just come up with 10, reasonably quick, gives you a score. It's been played a couple of million times at least. So we use that as a pre-test. The test itself is we then take the words from the DAT and ask people to use them when they're creating a verse. Right, that's it, reasonably open-ended, and they use a whole range of tools. So you'll see on the left, the tools are everything from a kind of co-creative tool, so that could be a piece of software, a support tool, so it could be a thesaurus, a rhyme and dictionary, something like that, and then an autonomous tool, which would be something like a large language model that would do the whole thing for you. What we didn't do is tell people how they had to necessarily use the tools, which we'll come on to at the end, and that had some implications. And then a post-test to obviously find out how people found the experience, as well as obviously analyzing the results. And effectively, and again, it's all in the paper, but just briefly, the results we tended to find is that there wasn't much of a relationship between experience level and a baseline rhyme performance. And all I mean by baseline is we started off by saying to everyone, just write rhymes in a piece of verse without using any tools, just to see how well they did, obviously, because that's important in terms of making sure that you've got a baseline, because it could be that everyone who does well on the thing is actually very, very good at poetry or writing lyrics versus those who don't. Positive correlation between the DAT scores and rhyme density across all the writing tasks, that seemed to be reasonably clear. Experience made actually a reasonable difference in terms of people improving a rhyme performance, and again, I'll come on to explain some of the limitations about that later. And then the final part was that the perceived usefulness tended to be higher with support and co-creative tools. And I think there's a reason for that that is to do with a limitation probably in the design structure, which I'll come on to in the discussion. So what we eventually, I think, discovered is that, so I should say, by the way, that the sample size is quite small. So it's difficult to extrapolate this massively because you've only got 30 people, obviously. And most of them were reasonably good at poetry at some level. So that could have obviously been a confounding factor. People tended to find the support and autonomous tools easiest to use. And I think, actually, interestingly, relative to the prior talk as well, is that part of the reason for that could be that the truer co-creation was actually very difficult. So what this particular tool did, it was called Verse by Google, is it created some lines of a poem for you. You could create other lines, and then it would give you other candidate lines. Our hypothesis is that probably the cognitive loading for people, it was harder using that, because you really needed to blend, than just either having a support tool like a thesaurus or a rhyming dictionary where you're going to do most of it yourself, or an autonomous tool where it's going to do most of it for you. That sort of halfway house thing, especially if it wasn't the style of poem that you would actually write, probably cognitively was the hardest thing for people, which is why they both tended to rate it less effectively, and also the results with that were less effective in terms of the kinds of poems that people wrote. And then the final point was that the nuance wasn't really captured across the study, because actually what you could have done is use a large language model to give you some candidate rhymes. You could have then actually changed that and actually co-written with it. What people tended to do instead is mostly just use it to write the whole thing. We didn't actually explicitly say that that's what they should do or not do, but that's what they tended to do. And I think that has implications, obviously, for the kinds of ways that large language models may work in this kind of study, and also for co-creativity. And then in terms of the future work, picture there, I mean, as a person who loves hip-hop, I hope that's not the future that we're looking towards, but is much more deeply personalized AI tools that will compete with people so that we can have something along the lines of an adversarial AI. Battle rap in particular, which is what this picture is about, is a reasonably interesting form to explore it because the competition is within the culture. And essentially the study that Mark and I are looking at, which we'll talk more about on Thursday, is the idea of a personalized AI that's a version of someone's self. We call them super twins, and they battle against it. And the idea would be that if you lost on the one hand, you might be disappointed, but equally, if it's trained on your lyrics and it sounds like you and it has your voice and your flow and your style, then at some level it's pushing you to become better, but at a very deeply personal one-to-one way. That's it.
Yeah. Perfect. I'm a little sad that I couldn't use this tool to warn you, but maybe the next speaker. Let's see if there's any questions.
I think this is a really cool idea that you guys are talking about, and I wonder, there's probably lots of things I'm not thinking about, but the one thing you were talking about that was making me think, okay, you said the AIs are a long ways behind in terms of doing these sophisticated kind of rhyming schemes, but if you take some lyrics from Eminem and just look at them on paper, or have me say them, they don't sound very rhymey. They sound often pretty bad, but a big chunk of it is the way he says the words, right? He kind of cheats a little bit, but in a clever way so that you can still understand it, but it also sounds like it rhymes. And lots of hip hop artists are very good at this, part of their art. And I wonder how we could account for that, or the AI need to be able to do that too? Or can we separate that out and make it apples to apples comparison? Does it make sense?
No, totally makes sense. It's an excellent question. I think two things. I'd slightly take issue that on the page they don't work. I think they do. I think there's best lyrics, but it's a fair point for sure in terms of bending phonemes and getting things to match and those kind of things, as well as obviously slang, right, and a whole bunch of stuff like that. I think in terms of the AI doing it, I guess it's a number of things. One is a more fine-grained understanding of phonetics, and phonetics as they're actually used. So a lot of things are based on the CMU pronunciation dictionary when you're going to use speech-to-text models, et cetera, et cetera. And so you have a limited range. So I think you'd need data sets that were probably richer. Probably the way that we would do it, and in terms of myself, the way we'd look at it is that we would actually analyze the sounds much more and patterns of sounds that are similar, and then try to predict, is this sound actually a word, as opposed to a sound that's not a word, to some extent, to answer your point. But I think there's an awful lot of cultural knowledge and richness in there. That's one of the things that makes it quite hard for the AI. So if you think of, let's say someone my age, I'm 54, and I listen to very modern grime, there's a whole bunch of that makes sense for people who are 10 years younger than me that have the cultural context to know what it means. But I would look at it on a page and just not get some of it. And so I think that's one of the challenges, at least, or why I suppose I'm reasonably confident that within hip hop and, which I think of as modern poetry, it's some way off for the AI, because without a kind of real world context for that, even the words themselves are changing all the time as to what they mean. That's a very, very difficult thing for a language model to capture right now. So yeah, I think there may be ways to approximate it, but there will be a gap, I think, for a while in terms of the lived human experience and being able to represent that in language and what an LLM can do. So does that sort of answer the question without fudging it or cheating?
Any other questions?
You see some examples, or I'm not sure if I miss. Did you have some examples, like some actual phrasings and poems?
Oh, what? So phrasings and poems in terms of?
Of this experiment. Maybe I misunderstood.
Oh, I see. Well, so the user participation ones, yes, I have quite a lot of them. Sorry, so yeah, now I understand, I think. Yes, I do. Not ones that I can remember. Most of the poems, I mean, they weren't, my wife took part, so I can't say they were all bad poems, so there were some really nice ones. But no, they were usually, so what we did is we gave people a theme, and the theme was usually about, I think it was related to where they live and the favorite thing about where they live. And then the constraint was that they had to try to use rhyme. That part was quite important. And they would typically be maybe 3 or 4 stanzas. And then we had a piece of software that would look at the poems and analyze the poems for rhyme. The way the software worked is it would take the phoneme. So English has about 44 different sounds, more or less, right? Different sounds, and they're the phonemes. And it would go through all of them. So if you think of a line of text, and I think to the piece earlier that I'd color-coded, in fact, one moment, I can go back to do it. Our software would do something like this. It was slightly more sophisticated than that. It would break it down, and then each of them was assigned a point, and then you would get a point for the overall amount of rhymes that you'd packed in to your fit. And then you have to obviously normalize it, because some people will do very long text and some people do shorter text. And that's effectively how it worked. Does that sort of explain, does that answer the question? But in terms of remembering any of them, no, that, alas, I can't do.
All right, okay.
Are the poems available for listening to? Are they, can we listen to that? No.
Oh, I see. So for this one, it's a good question. So this is my thesis project. At the moment, not, but the next study, the one that I'm doing with Mark, we're actually using the AI, we're cloning people's voices with their permission, obviously, then using the AI to have a battle against them. Those poems we will likely make available because the participants are okay with it. With this particular study that I did here, it wasn't a thing that we necessarily said that we were going to do. But the next one, yes, and then people would be able to hear them. And then what we would do is a large kind of trial, ideally, where you heard the human reciting their poem, you heard AI versions, and then it's a sense of whether people can actually tell the difference between the two. So that's actually the next study.
In this instance, you said that it was better as a tool, right, than as like a co-creator. What would have been examples of like using it as a tool as opposed to co-creation in the research?
Can you repeat that? Sorry, I didn't catch that.
What would have been the differences between like co-creation in this study specifically and then using it as a tool?
Oh, right, so yes. So I suppose there's two ways of looking at it. One is how the extent to which the authors considered the contribution of the tool or the software versus themselves. So what we found in this, and I think other research bears this out, is that if you looked at an autonomous tool, right, which would be GPT-4, generally speaking, people didn't like that much because they don't really feel that it's them. They don't feel it's reflected them. You put a prompt in, you left it, and that did the whole thing. If you looked at the other end, which could be a thesaurus or a rhyming dictionary, actually you still have to write the thing, you know, you have the authorship, you would feel that that's less co-creation because we wouldn't tend to say that I co-created with the dictionary, in a sense. So, and then in between is the co-creative tool where it actually creates a bit and enough, but probably people feel that they don't want to change it totally because it's there, then they build on it, but it's not a thing that they particularly liked anyway. The co-creation part, I think, for a lot of them was the hardest, to be honest, and the most frustration. They pretty much preferred either just to have a tool and do most of it themselves or just that it's all done. Right. The middle part was the hardest thing. So, yeah, does that?
Yeah,
that's
okay.
Good.
Thank you.
All right, and with that, we can thank Tunde. We have a slight change in the schedule, so we're going to do the last paper first. So I think, is Olga here in the room? She's online, so Olga will do it online. Yeah, supposed to be online. She's here. She's actually in the room. Okay, so we'll have her present first. Okay. We do have our presentation. But she's going to present online. Okay.
Okay, sorry, there's sound here.
Yeah, she can share her screen.
Olga, could you talk a bit so we can test your sound? Olga, are you listening?
Yes.
Oh, okay, great. So,
So Olga, you can share your screen, and whenever you're ready, I'll introduce you, although people already see you, and then you can get started. Okay? So can you share your screen? All right. Okay. All right, so the next speaker is Olga, reimagining dance.
Okay, can you see my screen? Thank you. Can you see my screen?
We can, but we basically don't see it in full screen. So you need to put it in full screen. Oh, so you have to put it in presentation mode. We don't see. Oh, we see a lot of screens now. Yeah. So it needs to be in presentation mode.
Okay, so
Yeah, it's perfect now. It's perfect now. Thank you. You can start.
yeah, can you see it now?
Yes, we can see.
Okay, so hi everyone. My name is Olga Vechtomova, and I'm going to present a paper that I co-authored with Jeff Boss from WordSynth. So what is the motivation for this work? Traditional dance and music follow a very strictly hierarchical relationship. So dance always follows music. Even in improvisational dance, the choreographers who provided initial ideas for the dancers, they're still guided by the initial composition of the score. With some exceptions, for example, live settings, maybe there's a live musician and a dancer, and both somewhat adjust their performances to each other, but still the musician follows some predefined ideas of the composition. So in this context, in the traditional hierarchical relationship, dancers are just performers and composers. So our idea was, what if we can invert that relationship? What if we create a scenario where the dancer will be able to express themselves and knowing that their movements affect the music choices, so the composition itself and its trajectory. So we are going from what is essentially a unidirectional relationship, music to dance, to a bidirectional relationship where music influences the dancers, and dancers are able to influence the music. So our key innovation is that we create a system that dynamically shapes the musical environments through the dancers' movements in real time. We envision this as a three-way collaboration. The first entity is the musician who contributes the initial music source material, and then the dancer who with the movements shapes the trajectory of that material, and then the system that actually is able to assemble from these initial snippets of music pieces based on the movement, the overall composition. So let me go to the diagram representing our system. So our system is based, it's a multimodal deep learning system. So on the left hand, you see the movement capture. So the dancers' movements are recorded in real time, captured using a webcam and TensorFlow MoveNet library, which captures the movements of different body landmarks, such as wrists, feet, and nose. So we use these 5 landmarks. And then these movements are converted into the trajectories that I'll show in the next slide. And they're then converted into the embeddings, so 128-dimensional vectors in the latent space using variational autoencoder. So we call this stream, this particular pipeline movement movement. And the second pipeline starts with the audio library. So as I mentioned, there is a one entity that takes part in that performance is the musician. So the musician records initial source material. So this would be loaded in the audio library, and in our experience, we used 50,000 clips. So these are split into small duration clips. So we use 3.5 seconds of audio, and these are then essentially are the material from which the ultimate composition is sculpted. So these audio clips are also encoded by audio variational autoencoder into the latent space. And then the movements are affecting the prediction of the next audio clip. And the audio clip that is predicted based on the movement is then seamlessly cross-faded with the previously played audio clip, creating this seamless audio composition. So this is not a generative model in the sense that it synthesizes music, but it works with the existing musical material to create the final arrangement of musical composition. So how do we represent the movement? So as I mentioned, we use the webcam, and we use the TensorFlow MoveNet library to do the pose estimation. So this composite image shows the, in still form, 3.5-second video as the dancer moves this initial position to this one. And during that duration, we captured the trajectories of the landmarks. So this green line is the left wrist, right is this blue, head is red, and purple and yellow are the feet. And this image is then what the system sees as the representation of that movement that happened in the time period. And audio is represented as spectrograms of audio during the 3.5 second duration. What is our training data? For training data, we need an aligned set of movements and the corresponding music that was played while the dancer performed that movement. So we assembled 18,000 aligned video audio clips, so these are 3.5 second long. So 17,000 came from the ICCC dance dataset that's publicly available, and 1,000 was from our own collaboration with professional dancers. And as for audio, we assembled, in addition to the audio that was available through IEAST and the 1,000 clips provided us by the dancer company, we also provided our own data set. So from our own studio recordings. And these are multiple genres of electroacoustic music. So some of it is more ambient, some of it tempo driven. So this is an example. So the system predicts the next audio clip. And as I mentioned, that audio clip is then cross-faded with previous audio clip. So the overall musical composition is as the dancer proceeds. So you can see here two inputs to the system. So the system input. So in this case, this is the image of the movement corresponding to that movement captured by the system. So it's a rather still movement. The dancer just waves her hands slightly, but the feet and the head are still. And the system also takes as part of the input the previously played audio to provide continuity. Because if we didn't provide the audio clip, the system would be very jarring, moving from one audio to the next. So this is the previously played audio presented as a spectrogram. This image here is what the system generates. So we use a generative adversarial network to generate the latent code of the next clip. And this is what the system thinks our next clip should be. But we cannot generate high fidelity audio from a spectrogram, so we then use a retrieval model to find the closest matching actual clip. So this would be the clip that the system found. And this is the clip that the system would play. So in contrast, we decided to alter, for instance, this person, we decided to alter the movement. So this is rather still pose, but this is actual breakdance move. And we paired it again with a very ambient music. So this actually represents a very calm piano music. And the system, as you can see, instead of predicting this rather calm next clip, it predicted something with a beat. So these vertical lines actually correspond to a rather frequent beat. And this is the top match. So the movement paired with the same previous clip was able to steer the system to predict a more dynamic music. And here's also what if we keep the movements the same, but the previous audio will. So again, you can see that if we the previous audio was more beat-driven music, then the system predicts again next clip would be more beat-driven music. This is a more stable ambient music. So we conducted a small pilot study. So this is a rather early stage of our work. And, we plan to continue working on it for the next 2 years. Professional dance company. So for our small pilot study, we
Olga,
recruited
sorry, can
three-
you hear me? Yeah, you're running quite out of time, so can you try to wrap it up in the next couple minutes?
and formal training. And we assembled 7 minutes of improvisational performances where we let the system run and record the dancers' movements in real time and play back the music as they dance. So what we found when we spoke to the dancers is that there's a fluid exchange of initiative. So the dancers reacted to the music, but also they consciously tried to steer the music in a certain direction. So sometimes that steering was unconscious. For example, the dancer experienced fatigue. Their movements became less dynamic, and the system adjusted. So the system started playing more ambient music. And when the dancer started moving more dynamically, then the system picked up the pace and increased the beat, for example. So so there was a true indication of a true bidirectional relationship between the system and the dancer. So we did some statistical analysis, and there is a supplementary material to the paper, and you can see the more detailed statistics there. But actually, the main takeaway from this is that the system seems to react more to the to the minimum movement. So when the dancer slows down and starts moving more slowly, then the system reacts to that. And yeah, so some future applications, in addition to being a more expressive framework for dancers, with dancers reacting to music and being able to shape music, we also envision this potentially acting as a new form of composition where dancers can actually create new musical pieces. And I don't know if there is time. There is a demo, demo video that we can see, but if there's no time, it's available on the supplementary.
Do you hear us, Olga?
Thank you.
All right, thank you, Olga. Yeah, can you hear us, Olga, or?
Yes, I hear you.
Okay, all right, so we are a little over time, but we have a possibility for 2 minutes of questions, or we can watch the demo. Do we want to see the demo? Yeah. All right. Can you show us the demo, Olga? Yeah, you can show the demo, Olga, if you still can hear us.
Okay, sure, yeah.
Okay, great.
So let me just make sure that the audio is not, doesn't have echo. Yes.
Share the sound. Yeah, I also am afraid we're really running out of time. So, Olga, we unfortunately can't see the sound, but maybe you have the URL, so you can show the URL
Sorry?
one more time. Yeah, we can't hear the sound, but we also have to move on. So thank you so much for your presentation. Thank you. I'm sorry for all of this. Maybe somebody can create an AI to help with conference organization, you know, maybe something for inspiration. We also have another change in the schedule, so I think, Mark, you are up. I don't know what you're going to talk about, so that's something you can, yeah.
Hi, I'm Mark Shepherd. I've been brought in at the last minute to kind of. I would have worn a shirt. That's the thing. So obviously he was going to be better prepared than this. So this is rather an extension of what we've been doing with Tunde, as an extension of the rhyme density work, and also looking at co-creational tools. This is the big chunk of work. We're actually working quite extensively on this at the moment with some data capture and some experiments, and we've got a large ongoing experiment running right now on this particular subject. So I'll be talking about battle rap as a framework for human-machine co-creativity. So in a sense, what we're trying to do is basically look at these key elements and look at how we extract linguistic and musical features from a piece or a rap in terms of, or a piece of music, etc. So we're looking for vocal cadence and rhythmical analysis, which we can then use to provide some kind of improvisational modification, which gets back to your previous question about how we look at the musicality of the rap, of the MC as well. So we can look at and also as we're looking through this, we're looking at limitations of the current large language models as well. So why battle rap? That's the big question. So with this, it's a sense of a high creativity challenge with rapid linguistic processing and improvisation elements. So you're focusing on rhyme, density, rhythm, and opponent interaction. So then basically that's the big problem we have in terms of creativity. You've got a more of a confrontational, adversarial field where you're actually pushing, using the AI in a sense to push the limits of the human's creativity as well. So this is what we're trying to do, is basically use as a method for computational modeling of battle rap itself, and seeing how effective it is as a creativity tool. That's the emphasis of why we chose battle rap. Because also because it's very difficult. That's also why we chose it. So yeah, we're looking at aims as AI as a collaborator, but we're also trying to balance the computational constraints and human creativity as well. So we don't want a machine which is going to do everything for you. We want to have a machine which is then enhancing what you do. So it's retaining your humanity rather than dehumanizing and just taking over your creativity. So we're trying to provoke creativity through adversarial interactions, as I said before. There's a lot of stuff on this slide which you can read later, but essentially we're looking at, the main questions are, do existing LLMs and other tools make us more or less creative? Which gets back to one of the previous talks in terms of that dance activities, etc., and whether the tool itself makes you more creative or not. We're looking at whether RAP can help support creativity. So again, looking at creativity, adversarial Turing tests, quantitative metrics, rhyme complexity, density, coherence, and audience engagement as well as a part factor with this. So we're looking at the effect of the human in the loop factor, where the humans are basically important in the whole creative process as well. So this highlights the need for further research in these areas in terms of human creative and computational tools, but also looking at an augmentation of human capabilities as well. So evaluation, we can evaluate. So essentially what we're aiming for with the tool is basically looking at creativity, not mimicry. This is the whole point of creating a tool, to basically enhance your ability to rap and create rhyme and make coherent rhyme, which is actually musical, has a perfect cadence, etc. And this human in loop factor is vitally important, because basically looking for, and one of the part of our work, which we're working on now, is looking at subjective evaluation from multiple MCs as well, to actually evaluate, is the rap itself intelligent, creative? Does it fulfill the factors in terms of rhyme density, etc.? Does it feel like a real rap? So this is essentially what the evaluation approach is more about, how we as humans evaluate the machine output in this very difficult environment as such. So we've got linguistic approach. So we're using generative AI and writing assistants. And so if we were evaluating LMs and related tools for writing tasks, but also what we're looking at is, on top of this, is looking at qualitative data in terms of how we interact, how the MCs themselves review the output as well, as previously said on this one. So again, brushing on with large text on this. So this is focusing around the LLM part of the work. So we're looking at basic usability as a main development, but essentially what we're trying to do is development of these adversarial learning strategies. So we're using generative adversarial networks, GANs, and generative adversarial imitation learning, GALE. So we're using these ideas to generate the lyrical input. That's only half the story. Of course, lyrical input, you can produce the lyrical input, and you can basically produce something which is a lyrical basically a text output, for example. But in music, as rap is a very musical genre, you're looking at identifying things like the unique cadence of the voice itself. So you're measuring rhythm, inflections, and dynamics in the voice as well. And what we're looking at with the beat level analysis, I was looking at the BPM of the voice in terms of how fast that is delivered, both a cappella and with music as well. So it involves the linguistics, rhyme density, etc., with the musicality in terms of the cadence and dynamics of the piece. So here, it's just a brief schematic of, say, if we look at the top line on the scale on the slide, we got basically, if you imagine the the triangles are words. The beats are the blue rectangles with a line. So the middle of the beat is a black line. So you place words around that. So basically, it's whether you have a word on the beat, before the beat, after the beat. And so the AI itself would actually could be used to use reinforcement learning to actually get to a target state. So essentially, what here you're trying to emulate the cadence of the MC themselves. So essentially, the AI would learn the actual where the word placement of each different word would sit in relation to the original MC's flows, particularly. So you're trying to aim for an emulative state of where the words sit in the music itself. So another problem we had as a creative tool, we're trying to go from speech to text. So we evaluate all the text, then we produce a different set of lyrics based around set key words around the first lyrical data set. Then we do text to speech. Now, text to speech current models, they don't have the same cadence as the original text, as original speech from the MC. So this is what we found in various different examples from using things from 11 Labs, DIA, Tachytron 2, Solera, etc. You see on this particular schematic is that the distance between how far it deviates from standard the input MC cadence is by the blue lines basically on this diagram. So you can see nothing actually fits in overall. Over the phrasing of the AI does not really match the phrasing of the MC. So we look at trying to warp these, the MC, the AI response to match the cadence response. So that's some of the work we're doing at the moment in terms of mimicking the cadence of the MC, so we actually get a reasonable sounding AI output, basically. So basically looking for a call and response, MC call, AI response. So lyrically, you're matching the input from the MC, but you're also matching the cadence of the MC as well as a co-creative tool. So here, again, using the battle rap as iterative, it allows an iterative phrase development. So basically, you do it over 3 rounds. Phrase 1, round 1, 2, and 3, and you have a best of 3 to see who actually wins that battle rap as well. So as we see here, human in the loop is fundamental for generation of meaningful creative responses here. So we're looking at cache responses, also adaptive rehearsal where we have pre-generated responses, and then we're aiming for true real-life generation with fully dynamic responses between the MC and the AI themselves. So under the hood, we've got this model where we interact with the MC. So AI is basically an adaptive discriminator providing feedback each time. So you're looking for an emulation, an improvisation phase. So the AI emulates the input from the MC and then improvises and then passes that improvised output to the MC to then create some inspirational creativity from the MC to produce another response. So that's basically the model we're trying to aim at here. So using standard tools in terms of LLMs, we explain lots of different LLMs at the moment, lots of frustration, and also lots of frustration in terms of digital signal processing, but it's a difficult nut to crack, but we are making a lot of progress with it. Again, implications, future work, we're looking at broad applications such as conversational AI, storytelling, but essentially we're trying to make the AI make you better at that creative task rather than the other way around. So yeah, that's pretty much it. Any questions?
Hi.
I thought you would have a question, yeah.
Very nice talk, thank you. I was particularly interested in the cadence warping that you're doing. I think the answer to this will be yes, but I wanted to double check. Do you think it could be used toward conversational? So when I've done voice cloning with local models, I've been very happy with the quality of the voice sound itself, but what's always been wrong is the cadence, right? And so I'm always
Yeah, yeah.
complaining, oh, this sounds great, but it doesn't sound like the original person's talk. So I would love to use something like that. You're deliberately going against conversational, but I want to bring it back. Would that work?
Yeah, I think it would work as well, because you basically, the principles you're using for this high-speed rap battle are essentially the same. It's just obviously faster words in a very short space of time, where each word is segueing into the other word. So it's actually that's quite the challenge in this. So some of the work we're doing at the moment, we're working on looking at poetry. So again, poetry has got its own dynamics, its own cadence, but very, very enunciative, very, very particular. And that's also interesting because we can actually then use that to model the cadence of the poet and then generate a response with an LM and then do text-to-speech and then basically take the... So what we're essentially doing is taking the speech, chunking it up, and then all you're doing is slotting it like Lego back into the original cadence tempo. So that's where we are at the moment. So, of course, then you've got things like the DSP smoothing. Because obviously, if we put a chopped-up word in a chunk like this, it's going to sound very chopped up. So you have to then think of ways to smooth it out. But essentially, the long-term analysis of cadence is that you would analyze quite a few cadence phrases in terms of cadence. And so you get an overall feeling of what that person would talk like in different situations. So you can actually start adding dynamics, which are weighted dynamics according to where you are in that particular word and phrase, which actually make that more interesting. Because also you can imagine doing cadence work, and if you put the same cadence, the same dynamic on all the words, it would sound exactly the same. So the challenge is, after the next iteration of that, is actually then to start putting variety in the cadence as well. So it worked for conversational, but I think the reason why we chose battle rap, because it was difficult, because if you're looking at a high level of MCs spitting out bars, is that there's a lot of words in there. And also, we're looking at the current tools in terms of the speech-to-text models, is that looking at limitations of them as well, because obviously it worked better if you've got clear enunciation, so the speech-to-text would be more optimal. But in a rap situation, you may not get the nuance of the words as well. And because you're dealing with slang, etc., it shows the limitations of those models as well. But yeah, thank you.
So in my experience in working with sort of large language models and co-creative AI, I've noticed that a lot of AI large language models usually tend to be very polite. And I can imagine that if you want to do a rap battle, you need usually there's
exactly,
more aggressive, more like dissings and sort of that kind of things. Is that something you ran into and had problems with?
I think so far with the work we looked at, it's been fairly, I think, because we've been using key, like target words, the target words in themselves have been quite innocuous. But there's always a possibility of putting in, F-bombs, etc., and things like that in there. So that's also a tricky thing. So basically, the evaluation of that would then to look at actually so you evaluate it from speech to text, but also then you'd actually, as a human, look at actually reevaluate the audio to see where the swear words were, and put them back in context. But again, because you've got this kind of like politeness filter in LLMs, this is the slight problem as well. Also, it may contextually, and also I'll pass it over to you in a minute. Yeah. So, but contextually, it may be a case of in different cultures, a word may be regarded as a swear word when actually it's not a swear word, for example, or may sound linguistically like a swear word. But I'll pass you over to my colleague there, Tunde, for the follow-up.
So two things, I guess. So one is, I suppose, the non-serious answer, which is there's always grok, right? Like grok's got enough of a potty mouth that we're probably fine. But joke aside, we picked a deliberate variation upon a usual battle rap. So battle rap typically is just going to be two people dissing each other for the most part. We picked some slight variant on that. So a variant is I think Eminem does one, and there's a rapper called Low Key in the UK who does it, where you get a bunch of keywords and you use them in real time and come up with spits and bars, which is way, way, way harder. Because typically, if you were using battle rap, people have pre-prepared it anyway because they know what the person looks like, or they Google them, they find some stuff about them, so they can make their attacks very deliberate. So A, it's not typically improvised that much, and B, it's specific insults against a specific person. From our point of view, what we did is we picked some other games that are relevant in the culture. So End of the Week, I think in the US also do another one where they have a bag. They pick out words at random, and then you have to use those. We picked those kind of challenges because they're much harder. And then secondly, you avoid the problem of, as you correctly say, you end up with the LLM being limited. So that's the way, from our point of view, that we can go around it.
Yeah.
Well, maybe that's also still for humans to do, to swear, so.
Drop the mic, you know.
Any other questions? Yeah.
So I was just wondering how you guys incorporate your work into your work, because you talked a little bit more about the sound of words and the different parts of word that had different sounds. And normally when you're working with LLMs, you don't have the tokenization process, for example, does not care about the sound itself, right? So how do you guys work together on that, right?
So in a sense, we work as a double-headed beast with this work as well. So obviously, Tunde is the wordsmith. I'm a musician. I'm a producer, musician, etc. But I've done many years in digital signal processing work, and look at dynamics, look at the interplay, looks at in terms of using machine learning to identify timbral effects in sound as well, which is also very important because we also work on voice authentication as well. So these two things really go hand in hand for us. We see them both as, you know, it's two halves of the same coin, basically. So, but in a sense, with words, I think with LLMs, I think the main focus has been on obviously looking for word associations and providing meaningful output, which is obviously intelligible to humans as a you know, question and answer type scenario. But we're interested in the musicality, but also conversational aspects of AI and LLMs. So with that, you have to have a musicality to the voice as well. Otherwise, if you don't, I mean, things like 11 Labs, Dia, they got some reasonable output, I think. Again, conversational, but it's good enough. And also it's quite varied because you don't get the cadence to the voice. So what we're aiming for is looking at systems which have your voice or close to your voice as well. So then there's that believability. On one other side, in terms of that's a really hard nut to crack. I'm also a neuroscientist as well. So in terms of the way the brain works and processes audio and also speech is very, very quick. So the brain will understand when something's wrong within 50 to 300 milliseconds. So this is the challenge that I think in LLM, well, text-to-speech particularly, this is the problem we have in terms of obviously combating deep fakes, etc. But in a sense of creating more conversational co-creative tools, this is the problem, because otherwise it ends up like talking to, well, even when you think about C-3PO had a voice, didn't he? Because obviously it was an actor, but he had a cadence. Everybody's got a cadence, but whereas a machine voice has a cadence, but immediately becomes very, very boring after a certain length of time. So we think this is important to increase creativity, but also make systems more human.
The game that we're developing at the moment, or the experiment, is that you reuse the person's actual voice. So in one test with poets, what we use is text-to-speech, standard. And it's okay-ish, but as you can imagine, poetry isn't, I suppose, rhythmically necessarily as complicated or certainly as fast as MCing. Then in another experiment, what we do is we take the flow from the MC and we effectively remix that with some text-to-speech as well, and we blend it. That's the idea. And the idea is, I mean, if it works, because we've still got to do it, is that if it works well, what will happen is if you can blend it well enough, people would think that it's like them, but more importantly to your question, they would actually have the nuances and the rhythms because it was their voice. So it's a blending process. And then the actual end goal at some point would actually be to have something like an LLM with a speech-to-speech model that actually replicated both your speech, your rhythms, your intonation, the timbre, all of those kind of things. But that's obviously a later stage.
Thank you, and congratulations on the presentation.
Thank you.
Both of you.
Thank you.
All right, thank you, Mark. So this brings us to the end of today's first session of Co-Creativity. There's another Co-Creativity session on Thursday without Mark, because he did it already. And if you're interested in more co-creativity, I'm organizing a secret workshop at 5:30 today. So if you're interested in that, come see me and talk to me what this secret workshop is about. But beyond that, there's the co-creativity session on Thursday. And let's do one more thanks to all the speakers. And now I believe there's a coffee break, so enjoy.
presented with